Okay, well, welcome everybody. This is the second Design and Discourse of 2024. Today we're featuring Colleen Harman and Jared Schneider, who are both really focused in the impact of the environment and your emotions, your memories, and how you feel. So both of them will have very unique perspectives on these. We'll first do about 20 to 30 minutes for each presentation, and then following them, we'll have an open discussion. So please keep your questions. You can type them in the chat if you'd like, and then we'll get to them afterwards. All right, so I am going to hand over the floor to Colleen.
All right, I'll share my screen. Okay, so I'm Colleen, and for my capstone, my topic is called Engage, the Human Need for Intentional Spatial Connections. And so today I'm breaking it down into a few different key points, starting with first, why do humans need engaging spaces? And then breaking it down into two key main research topics that I dove deeper into, the first being the influences on perception of space, and the second being emotional responses to elements within a space. And then I'll jump into an overview of where I'm going now with an overview of my project and my key project objectives. So to start, why do humans need engaging spaces? There's quite a few different reasons, and so I broke it down into four main categories that I'm focusing on. The first being for psychological well-being, engaging spaces with stimulating features such as natural light or varied textures can boost mood and mental well-being, whereas the complete opposite of that, more dull environments can lead to boredom or stress and depression, which leads into sensory stimulation, which can actually help with psychological well-being. It enriches the overall experience and evokes emotional responses, which can promote a sense of immersion and connection to space. And so with these emotional responses that require some emotional connection within space, which is the third one, and spaces can evoke emotional responses through sensory stimuli, which then will influence an individual's moods, feelings, and perceptions. And then the fourth one being spatial interactions, because the built environment can influence the exchange of these connections throughout. And so all of these are very interconnected, but they're all different thoughts on diving deeper into research of how to create an engaging space. And so the two main topics, like I said, the first being influence on perception of space, and the second being the emotional responses to elements within a space. So first, the influences on perception of space. So I looked at a series of experiments that all had a play with the role of textural influence on spatial perception. And so the study focused on investigating the impact of wall texture on human perception of spatial scales within these interior spaces. So the objective was to identify the elements of texture that influence the perception of spaciousness, and then understand these underlying principles about them. And so it's broken down to three different hypotheses about this experiment. The first being that wall texture does impact perception of spaciousness indoors, just a matter of how. And then the impact of wall texture varies depending on room size or the observation distance from the textural wall. And then third, the degree of influence is based on the associated meaning of texture. Do we associate specific degrees of space with texture? And so then how is this done? It's done by looking at relevant literature and then conducting experiments in an interior virtual space based on these. And so the first experiment was done with the influence of wall texture in a similarly sized room. The room is the exact same size. The only thing that changes is the wall texture. It was done with 34 participants, all from various academic backgrounds, and they used a magnitude estimation to rate these room sizes with these 9 textures. All 9 textures are shown in the image, with wood, tile, concrete, brick, gray paint, metal, frosted glass, and linen. And so to observe these, they were given VR headsets, and the participants viewed the standard and modified rooms for 15 seconds each. It was then scored on a baseline score of 100, and the chart shows these ending scores based on this scoring chart. And then there was a few different control measures, the first being that there was an ensured constant luminance as well as it being a quiet environment. And the participants solely focused on the room size rating to avoid bias. And so out of this experiment, there's two main takeaways. The first being that wood walls are perceived as the most constricted and white linen walls are perceived as the most spacious. And this shows that there is the presence and the type of wall texture will influence perception of spaciousness for these similarly sized rooms. And so then moving into experiment 2, this one was done very similarly, except for they were on different sized rooms. And so the objective was to investigate how wall texture influences the perception of spaciousness across these different room sizes. The experiment was set up with uniform ceiling heights within every room. The only thing varying is the dimensions. And there was 32 participants. And then as the procedure, they introduced these additional rooms of various sizes based on standard function rooms and architecture. And then the most important part is what was the stimuli. Each room had a white-walled room as the standard, and then they had 3 textures: wood, ceramic, tiles, and linen. And then they followed that same methodology as the first experiment for consistency. And so after analyzing these results, I took away 2 main results that are key in looking at how to create engaging spaces. The first being that the effect of wall texture on perceived space does vary with room size, and it's noticeable with linen walls, where that textural effect diminishes as the room size increases. And so this is shown with that green line in the chart. And then another key thing that I noticed was for wood walls, that the value is lower in the mid-sized room compared to smaller or larger rooms, which actually suggests that there's an optimal scale range of visual aggregated elements that accentuates the textural effect on spaciousness in those medium-sized rooms. And that's shown with the blue line. And then the red line shows the tile, which is more up and down. Most contrast was with that wood wall and that linen wall. And so then how do we combine all this? This was the role of experiment 3, because texture and perception, it's not only the visual patterns, but it's also what we associate to these textures and building materials, because people associate meaning to specific textures. And so this experiment's hypothesis was that people have individual associational meanings of material textures and that affect their perception on space. And so again, I broke it down into a few different results that are key in looking at final project outcome based on research to create different engaging spaces. So the first being in small rooms, it perceived that wood walls as hard or reflective is actually linked to a perception of less space, while associating linen walls as non-directional is linked to a perception of more space. So this result is very similar to that of experiment 1 and 2, showing that wood walls are perceived with less space or more constricted. And then another one was that in larger living rooms or compact offices, it's interpreted that ceramic walls, the texture depth is flat and it's associated with perception of less space, just based on size. And then a medium-sized classroom or meeting rooms are associated wood walls with complexity, frosted glass with elasticity, metal walls with no inelasticity, and then concrete walls with more naturalness, and it's linked to a perception of less space. And so all these things can also be taken into account when looking at users of space and how people associate meaning to their textures. And so then another key point that I looked at was the emotional responses to elements within a space. So this is a study that was done that associates emotions with different textures during touch. So looking at the tactile approach to elements within an interior. So the study explored the relationship between the textures and then 6 basic emotions: anger, disgust, fear, happiness, sadness, and surprise. And so how did they do this? They employed a survey to nominate different tactile sensations, and then they could pick specific emotions from that. And so they selected 21 textures based on the nominations to create this experiment. And then within this experiment, there was separate groups of participants that physically touched the chosen textures, and then it evaluated their emotional impact on 6 different scales. So the findings revealed consistent associations between certain textures and specific emotions. One of those key ones that the element of surprise, that feeling, is notably linked to all textures. And so what was the influence of these texture characteristics? It suggests that temperature and softness and roughness of textures can influence emotional associations, as well as softer materials like fur, velvet, silk, and leather are linked with positive emotions, whereas others like rough materials like sandpaper induce these negative emotions. And so the study concluded that the studies had emotional ratings that proposed to be valuable for people to explore the emotional responsiveness to these tactile stimuli, which is important when looking at creating these engaging spaces. And so to further show this, here are just some charts with some of the results. The first chart shows the medians and the interquartile ranges, as well as those full ranges of the intensity ratings of these emotions: anger, disgust, fear, happiness, sadness, and surprise. And then I highlighted just a few key points based on responses. So the first one being happiness, whereas fur and velvet are some of the more ones that evoke this emotion of happiness, whereas elements like an acupuncture mat or a sponge are more fearful. Disgust, for example, toy slime. And then surprise, there's an element in every single one, whether it's just a rating of 1 all the way to the rating of 4. So this is just a better overview of how to look at these emotional responses. And so where is that taking me now? So my project overview, I am looking at the profound impact of intentionally integrating these various textures to enhance human experiences. It's by engaging these tactile, visual, and auditory sensations to show how intentional textural choices shape sensory experiences and spatial perceptions. The goal is to provide insight into the way design can fulfill the human need for connection within the built environment. So specifically looking at applying different sensory strategies to the same exact space, and the project will highlight how these intentional design influences a human's engagement to the diverse interior environment. So within the same space, it's a storefront, and within those, one will be a climbing gym, one a bookstore, and one an eatery restaurant, all of which have diverse users as well as diverse needs to create a space that connects the users to the space. And so from that, my key project objectives is 1, to integrate the tangible and intangible design considerations that influence engagement to spatial experiences. And then secondly, to reduce the common emotional, spatial, and physical barriers that exist within the current storefront model. And then thirdly, to create those contrasting storefront spaces that reflect the multisensory elements they contain to achieve an engaging space for designated users that elevate the sensory experience. So overall, the goal is to take the research that I've learned, such as the experiments and the study on emotion, and apply those to a similar space to really show the diverse needs within and the function that texture has within a space. And that's all I have. Thank you.
Thank you so much, Colleen. Your project sounds really interesting. I can't wait to see how you apply that research and where it goes.
Thank you.
Right. So next up, we have Jared, who is asking the question, can the built environment affect memories, or how? We shall find out. Take it away, Jared.
So hello, my name is Jared Schneider. I appreciate you guys taking time out of your day to listen to this on a Friday. So as Kim said, I'm focused on designed memories and how the built environment can affect those memories. And this came about when thinking about how many times I moved as a child. I moved quite a bit, and I remember specific things about each house. For example, one home I lived in was in front of a grape vineyard, and I remember the smell of grapes. Another house, I remember an unfinished staircase that I always had to wear shoes on, otherwise I'd get splinters. And so this brought up the question, how does the built environment affect memories? And what what sort of aspects engage in creating those memories. So the first thing I asked myself is, what is memory? And so memory is referred to the psychological process of acquiring, storing, retaining, and later retrieving information. And neurons have a huge part in this process as they facilitate the transmission of information to the brain through the synaptic bulbs, which connect to other neurons, enabling the transfer of information to them, kind of like the flow of electricity. So after figuring out, okay, what is memory, I asked myself, what kind of storage does our brain have for memory? And there was two types that I found, short term and long term. And short term is comprised of two different components, conventionally labeled as short-term memory and working memory. And in short-term memory, the brain temporarily stores information for immediate repetition, like recalling a phone number, seen on TV. And a working memory involves storage of information for one's purpose of manipulation, such as remembering a set of numbers while solving a math problem. For long-term memory, this process enables information to persist in the brain for an extended duration, and there's no exemptions from potential risks within the brain. And information can be stored in long-term memory, can endure for a brief period, say a day or a week, or extended throughout an entire lifetime. And you can remember explicit memories automatically, like driving a car or when you're aware of actively trying to remember explicit memories. And this can be further divided into episodic memories, which contain events that happen to an individual, or somatic memories, which contain general knowledge. And both of these are stored in the temporal lobe within the brain. So after figuring out what is memory and where they're stored, the next question I asked myself was, how do I acquire these memories? And this is when I stumbled across encoding, which is the method by which information is required, and it involves intake, comprehension, and modification of information to enhance its storage capabilities. And it's usually encoded through one or more of these methods, visual encoding, acoustical encoding, and tactile encoding. Victoria Suss uh, describes visual encoding as a neurocognitive mechanism by which visual stimuli are converted into mental representations, thereby enabling their storage retrieval within the human memory system. And so, for people who are not doctors, what that means are when our eyes take in information, the encoding process changes the way the information is stored to allow it to be put into our storage system within our brain. And we have different receptors of visions. Your eye works like a camera, and when light hits it, a molecule called retinal reacts and teams up with a cis-retinal and a protein called rhipsodin. This makes the rhipsodin change into a meta-rhipsodin, and another helper, transducin, jumps in, changing chemicals and closing channels that let in sodium in the dark. This whole process tells your brain it's getting brighter with a decrease in a chemical called glutamate. Simply to put, when light reaches your eyes, it sets off a chain reaction telling your brain, hey, it's getting bright out here. And there's different types of visual encoding. You have face encoding, picture encoding, and color encoding. I don't know if you guys remember a few years ago, there was a dress that went viral, for some people seeing it as white and gold and some people seeing it as black and purple. And that right there is a great representation of what visual encoding can be. And some of the pros of visual encoding are its improved recall of visual information, faster encoding, increased accuracy, and enhanced comprehension. And of course, when you have pros, you also have to have cons. So some of the limitations are it's limited by visual perception, has a limited capacity, misleading visuals, and it's subject to interpretation. Next, we have acoustic encoding, which once again, Victoria Suss refers to this as a neurocognitive mechanism by which auditory stimuli are converted into mental representations, thereby enabling their storage and retrieval within the human memory system. So just like your eyes, when our ears take in information through sound, our encoding system then allows it to be that information to be changed into a system or information storage type that allows our brain to store it. And some of the receptors, we also have receptors in our ears as well. And when we hear sound, it makes our eardrums vibrate and travel through tiny bones called the cochlea, which are filled with liquid. Hairs in the cochlea act as sound sensors, communicating with the brain. And when sounds make these hair cell bend, it open up channels, causing an electrical change. This change sends a message to the brain through the auditory nerve using a chemical called glutamate. The brain identifies the sound based on where the messages come from in the cochlea. So some examples of acoustical encoding are, remember, a warning sound. I'm sure we all know very well the Apple alarm clock sound. I know for me, when I hear that out and about in public, the first thing I think of is, I'm awake, I'm ready to go. Where do I go? Where do I need to turn this thing off? Some other things are recalling a teacher's lecture or learning a foreign language. Some of the pros of this is it enhances multisensory learning, promotes active learning, supports learning, and boosts memory retention. Some of the limitations are susceptible to interference, limited capacity, has similarity confusion, and has a language and cultural barrier. Next, we have tactile encoding, which is located in the parental lobe of the brain and is instrumental in processing encoding of tactile sensations, which pertain to the perception of how something feels, primarily through touch. And neurons in this region play a crucial role in the sensory process. The proprioception can be thought of as your central nervous system. It's like your body's GPS. It helps you know where your body parts are and how they're moving. It gets information from your eyes, muscles, and joints about pressure, movement, and stretching. Then your brain uses this info to create a mental picture of where your body is and how it's moving. Some examples of tactile encoding are processing of odors, the feeling of cuddling with your cat, remembering a taste of fruit. So when I said the example earlier of how I remembered the house that was on a grape vineyard, and I could remember the smell of grapes, what that was my body tactile encoding that home and that memory into my brain. And some of the pros are it's omnidirectional, it displays 3D information, it works well with visual and acoustical at the same time. And some of the limitations are it's low bandwidth for information transfer, it can be attention narrowing, and it may be difficult to detect stimulation when moving. So after learning about encoding, I wanted to get into some ways that you can sharpen and damage your encoding. And the first thing is schemas, which is using shortcuts to access information may hinder the retention of information beyond specific shortcuts being employed. So as a kid, I really struggled with spelling the word awesome. And so my mother came up with a chant that I used to say, AWESOME, which reminded me how to spell awesome. But while that shortcut reminded me how to spell it, it didn't help me remember what that word meant. And so the schemas, while it may be a specific shortcut, it may help you remember a certain thing, but will not help you remember everything. Then you have chunking, which is the concept of organizing information into groups, which facilitates the retrieval of an individual items from the group. Deliberate practice, which is pretty self-explanatory. Consistently practicing a skill enhances the ability to retain information. Economize your brain use. By avoiding constant mental effort needed to remember trivial details, such as the location of your keys, you can focus on better learning and remembering important information and utilizing tools like planners, maps, shopping lists, etc., to make most of this advantage. Lastly, we have space it out. Repetition is most effective when timed appropriately. It's not beneficial to repeat information in a short span, such as cramming for an exam. Instead, it's more advantageous to space out repetitions over extended periods. I'm sure most of us have been studying for a test and crammed all that information the night before, and as soon as we take that test, half that information leaves our brain. And so that's what happens when you don't space out repetition is a lot of it gets crammed in and then your brain has to make space for other information. And so a lot of that information leaves. So it's you need to space it out more. Next, we have ways to damage encoding. So we have sleep deprivation. And it hinders the brain capacity to form new memories during the day. Doctors recommend 7 to 8 hours of sleep daily for optimal brain functioning. Depression can cause damage to encoding, as presence of depression and anxiety significantly impairs an individual's ability to perceive and think clearly. Drug abuse, short-term use of cocaine, nicotine, and alcohol enhances the hippocampus-dependent memory, but withdrawal causes disruptions. Opiates and cannabis initially impair memory, but their withdrawal is linked to memory enhancement. So while you're taking these drugs, it's going to destroy your ability to retain memories. But as soon as you get off said drug, your memory retention starts to repair itself back to its normal state. Excessive multitasking among students and young adults prevents focused attention on a single task, resulting in memory encoding failures due to insignificant attention allocation. Vitamin B12 deficiency is vital for health of nerve cells and red blood cells, and a deficiency in vitamin 12 impairs the proper functioning of nerve cells. So after we're done here, make sure you go out and get your B12 vitamins. So after looking into what is memory, how does information get to our brain, how is it stored, and how do we acquire these memories, I wanted to look at some spaces that have been designed to really focus on the encoding. And so one of the projects that I found was DIY SOS Home, and it was erected in 2018. And this dwelling was meticulously crafted to cater to the needs of a family confronting impairments and disabilities. Stuart is a single father grappling with multiple sclerosis, a condition impacting the central nervous system, leading to difficulties in speech, writing, and walking, and is the focal point of this design. Lynn, Stewart's mother and primary caretaker, has navigated life with legal blindness since her 20s. And the family is further compromised of Stewart's 15-year-old daughter, Lauren, who also calls the specialty design home. So this project had three core objectives: enable Stewart to navigate through the home effortlessly through his wheelchair, grant Lauren the autonomy to have her own personal space, and facilitate Lynn's permanent relocation into the home, ensuring accessibility for her visual impairment. And they did these by repositioning the front door and staircase to create necessary space for wheelchair maneuverability, incorporating voice-activated windows, blinds, and lights seamlessly accessible for both Stewart and Lynn, utilizing minimal loose furniture pieces to diverse textiles in Lynn's room, adding an extra kitchen specifically for Lynn to alleviate any concerns about placement of items, and establishing distinct zones within the home, excuse me, through the use of various flooring types like tile, carpet, and LVT. And so this design here really helped me understand the importance of different tactile materiality to create zones within a home to help someone with a visual impairment make a mental map of where they are in the space. Realizing that tile is the entryway, or carpet is her bedroom, wood floors is the living room, really using that materiality to help make a mental map in their head. Next, we have the So-and-so Studio Home, which was also constructed in 2018 for a woman with visual impairments. This residence was meticulously crafted using the principles of natural adjustment and wayfinding. And during the space planning phase, the designers collaborated closely with the end user to map out the customary paths she navigated, promoting an intuitive organization that minimized the time required for the client to familiarize herself with the layout of the home. The residence is designed with a central spinal corridor strategically incorporated to eliminate any maze-like confusion and optimize efficiency and navigation. The central pathway seamlessly connects through three entry points: the garage, the front door, and patio, providing convenient access to all exits throughout the home. This was very intriguing to me as designing uh, a home for memory. Having a central corridor will alleviate some of that overextension of trying to memorize your house and figure out where things are. Having a central corridor makes ease of access of remembering where each each space is located within the home. They also employed the concept of a simple glyphic language, wherein images or figures convey words. They harness the linguistic approach for wayfinding, utilizing a combination of stone and wood in the flooring. They ingeniously devised a series of simple combinations to craft their unique and intuitive language. So what they did was they created Braille through materiality in the floor with stone and wood to create representations of where to stop, continue, the functional connection, directional indicator, a multi-directional and functional combination. And so this project here really helped me understand, while zoning is a great way to use materiality to make a mental map of the home, using different materiality within those zones can also create its own language to further enhance the ability to lose that confusingness that some people with visual impairments have. And that is all. Thank you for listening.
Thank you so much, Jared. I can really tell you're passionate about that, and it's really interesting. I am going to open up the floor for any questions, and I think I might just start with the first one. Both of your and this is for both, either, Colleen or Jared or both. I'm just curious how you would define engagement or engagement with the environment, because it seems really important for both of your projects, but you have different perspectives.
I think for me, it's looking more specifically at who the user is and what you're trying to engage with in the space, which I think like even for like where I'm going with it, with like having the same space with different uses. For example, like a climbing gym, like who are the users that are using that, and what do you want them to engage with within this space to focus on those elements. So I think it's more the connection of what you're trying to achieve for the function of the space.
Yeah, just to piggyback off that, I agree. With memory being something that's prevalent in this engagement and how that affects someone's ability to remember that space, it's very important. And so looking into different materials or even different aspects of the home that isn't just necessarily materiality, but different ways that people can engage in a space that will make them remember.
Yeah, so with engagement and designing it to the function or the user, as you both have kind of talked about, what steps would you first take, now that you've done all of this research and you're translating it to an applied design? How do you begin to assess those user needs so that you know specifically how to go about those engagement strategies?
I know for me, I've started by looking at each space specifically and thinking what emotions and what feelings do you want the space to evoke in order to create what specifically those next steps should be for creating like specific engaging spaces within it. And I can pull different things from research based on what it's trying to be achieved for the connection there.
Yeah, I fully agree with everything Colleen said. Very well put.
Yeah. Yeah. So I'm really curious, Colleen, there's so many different design elements out there, and you've looked at all of them. Both of you have really looked at all the senses and the elements. But you kind of really chosen to focus on texture. What is what is your underlying reason for that? From a design perspective or maybe a personal perspective?
Yeah, I think even just like looking at multisensory in general, I did a lot of research on just like what that is in general, and almost everything is tied back to the tactile experience with it as well. Even like looking at the experiments in the emotional study with looking at how specific textures, when you touch them, they evoke certain emotions. I think even that like just shows how like visually those same ones can, like the linen wall, it had an effect when you touch it as well as even just visually looking at it. And so like carrying the tactile into those other elements, because it will be kind of all encompassing, but with a focus on specific tactile elements.
Yeah, Jared, when you were talking about vibrations, I find that very fascinating in how the environments can have vibrations. I mean, we know sound has vibrations, but everything technically has some kind of sound. And thinking about even just standing in nature or next to that linen wall, what is the effect of those vibrations in our ears and therefore, our cognition? If there's a relationship there between the tactile and the effect of the potential vibrations they might have that help evoke those emotions. It's a
Yeah,
really nice dynamic, the two projects that you have going.
for sure.
All right, any questions from the group? Feel free to post them in the chat. We've got a lot of first year students on the call here who just finished a textiles course and started exploring all of that. We'll see. Feel free, if anybody has a question, feel free to unmute as well. Okay. Well, all right. Okay, I will take that as no questions at this time. Thank you so much, Colleen and Jared. Really fascinating. Really looking forward to seeing where these go. So congrats on your accomplishments so far. And that will conclude today's Design and Discourse. Thanks, everybody.
Thank you.
Thank you.